All right. Before we get into section 5.3, just wanted to do a quick review from 5.2 and the number system. I know there's a few questions out there on it, and I'll try to do a better job explaining here. Right. So the most basic number system we have is called natural numbers, and it's just the counting numbers. So 1, 2, 3, 4. So natural numbers, just we start at 1 and we keep counting 3, 4, and I could keep going forever. All right, but I'll stop there. And the dot 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 means it keeps going. Now, whole numbers, okay, consists of all of these natural numbers plus we add 0 to that. Now, integers, all right, are all of these plus -1, -2, -3, and that keeps going in this direction. Now, so integers, right, are whole numbers, natural numbers, plus we add on the negatives. Now, rational numbers are all of these, right? Natural numbers are rational, whole numbers are rational, integers are rational. And then we add in fractions, right? Like I could put in here 1.5, and I have decimals, right? 2.75, right? Decimals that end or repeat. And so rational numbers add on these values. So the easiest way to determine what number set or number sets a number is involved with is to start at where it's introduced, right? For example, if I have the number 5, okay, the number 5 is a natural number. Well, it's also a whole number, it's also an integer, and it's also rational. So if you look here, if my number starts in the natural, right, means a positive whole number, it would be natural, whole, integer, and rational. Now, if it's 0, right, that's the only number that is introduced in the whole. So 0 would be whole, integer, and rational. All right. Then let's say that I have the number -1. Well, that's introduced in this ring right here. So it's an integer and it's rational. Okay. And then if it's introduced in the rational area, meaning it's a decimal that ends or repeats, right? So here, this is a terminating decimal. This is a repeating decimal, or it's written in fraction form. Okay, those are all rational. And if that's where it's introduced, if it's in this ring, outer ring, that's the only one that it is. Now, if it doesn't fall within any of these rings, then it's not rational, right? And the only numbers that we looked at are right here. It's a non-ending, right? The dot, dot, dot tells me it doesn't stop. And there's no pattern, right? There's no bar over the top or no pattern that I notice here. That would be the type that are not rational. All right. So if you find it in here, it's natural, whole, integer, rational, right? If it starts in here, it's whole, integer, rational. If it starts in the integer, right, a negative whole number, it's just an integer and a rational. And then if it's a fraction or decimal, that's just belongs to the rational set. All right, let's get into section 5.3, which is multiplying fractions. All right, and we started the beginning of the school year with multiplying fractions, and then before break, we reviewed multiplying fractions. We're going to add on to that today. All right, we're not just going to multiply number fractions, we're going to multiply algebraic fractions, right? And those are fractions that contain one or more variables. And then we're going to use dimensional analysis to solve problems. And you've done that before. A lot of times in science, you've done it in math before. It's just including units of measure when you compute something. So miles per hour, gallons per mile, cost per gallon, right? So different units of measure. So let's look at multiplying fractions, right? We'll review the ones we've been doing. We'll also look at multiplying mixed numbers, right? Like number 4, where it has a whole number and a fraction that's mixed. And then we'll just look at multiplying by whole numbers, like number 7 and number 8. So first off, when we multiply fractions, we multiply straight across, right? So really, this is just one big fraction with a multiply sign here and a multiply sign here. So on top, I have 1 times 3, which is 3. And on the bottom, it's 2 times 4, which is 8. And we always want it in simplest form, right? Or simplified form. Let me clean that up a little bit. Right? Simplified form, meaning that there's no common factors where I can reduce it, right? Because let me give you an example. 1 over 2 is the same as 3 over 6, 4 over 8, 50 over 100. These are all the same, but this is in simplest form, cannot be reduced, right? And we looked at a number of ways. We looked at finding the greatest common factor. We looked at prime factorization, where we crossed out all the common factors. So you can decide what way you would like to do it. And it doesn't matter when you simplify. You could simplify first, or you can simplify second, and we'll look at one of each. All right. So, for example, here, if I'm multiplying this straight across, 4 times 3 is 12, 7 times 8 is 56. Well, I know they're both even, so it's at least divisible by 2, but I know that 4 goes into both of these. 4 goes into 12 3 times, and 4 goes into 56 14 times. So I end up with 3 over 14. So notice I divided it out at the end. Now, the other option, right, and it might save you some time at the end, is looking here, right? Top and bottom will cancel, meaning 4 goes into 4 once, and 4 goes into 8 twice. Okay, 3 and 7, no common factor. So now I'd have 1 times 3, which is 3, 7 times 2, which is 14. So here we reduced first, and we ended up with the last answer, or we can multiply and simplify second. The order does not matter. All right, so we'll go multiplication, right? This is just one big fraction. So I'm going to look for common factors first. I know that 3 goes into 3 once, and it goes into 12 4 times. 5 and 8 and 5 and 4 do not have any common factors. So now I have negative 5 times 1, which is negative 5, and 4 times 8, which is 32. So negative 5 over 32. All right, with mixed numbers, all right, we looked yesterday at changing these to improper fractions, and that's going to be your best bet, right? So I'm going to go 5 times 1 is 5, and then I'm going to add that remaining fraction there. So 5 and 2 would give me 7 fifths, right? That's my denominator. Over here, 2 times 2 is 4, plus 1 would be 5 over 2, right? This is multiplication. So I'm just going to make this multiply here, right? And then let's reduce before going in. I can see that 5 goes into 5 once, goes into 5 once. So now I have 7 times 1, which is 7. 1 times 2 is 2, okay? And this is okay to leave your answer like this, all right? But the answer key, or if it's multiple choice, it might not have it in that form. So we want to be able to switch it if needed, right? 2 goes into 7. Actually, let's write that up here. 2 goes into 7 3 times, right? And there would be a remainder of 1 over 2, right? And we can go long division, right? 2 goes in there 3 times. Sorry, I ran out of room. Right, 2 goes in there 3 times. That's equal to 6. So I have a remainder of 1 out of 2. Okay. So take a minute, and actually let's do this together because we have to remember our integer rules, right? Here I have a negative fraction times a negative fraction, right? Negative times negative should be positive. Okay. So let's see here. Can we reduce? I know that 2 goes into 6 3 times, and 2 goes into 4 twice. So negative 3, right, and I have to make sure I leave that negative. Negative 3 times negative 3 is positive 9, and 5 times 2 is 10. See if you can do number 6, right? Change that into improper fractions and then multiply. So pause the video here and then come back and see how you did. All right, working with some bigger values here. And first off, remember we have a positive times a negative, so my result should be negative. Okay, so this should be 17 over 8, and this one would be negative 11 over 3. So I could have negative 187 over 24, or, right, if I'm going to go mixed number, 24 goes in there 7 times, and there's 19 left over. So negative 7 and 19 out of 24. Now, multiplying by whole numbers, okay, really, this is not just 3. I can write that as a fraction, which is 3 over 1. So here we would have 5 times 3, which is 15, over 7 times 1, which is 7, right? Or, right, 7 goes in there twice, right? 7 times 2 is 14, so there's 1 out of 7 left over. So either way there. Right here, again, going in, we have a negative times a negative. So I have negative 1 over 3, and this would be negative 4 over 1. So negative times negative is positive 4. 3 times 1 is 3, right, which is fine, or goes in there once with 1/3 left over. Either way is okay. All right, getting into algebraic fractions, right? And this is just combining the simplify problems that we did in chapter 4. All right, so again, the order in which we do it doesn't matter, but we have to make sure that we're simplifying the correct way, right? So here, I have 2a times b squared, right? Which none of these are like, so I'm just going to have 2ab squared. And on the bottom, I have 5 times 3a, right? So I can multiply the numbers together. 5 times 3 is 15a. Now, this is where this is the problem that we would had in chapter 4, right? It would just say, here's your problem, simplify it, right? The only difference here is we have to multiply first to get here, and now we have to simplify. So 2 and 15 have no common factors. Oh, let me erase that. Terrible with my 5s, but let me change the font to, let's go here. So we'd have 2 over 15. And then a over a. So remember, we can cancel out, right? That's just equal to 1. And then there's no other b, so that would be b squared. So it'd be 2b squared over 15. All right, let's see the next one. So I have 5a squared b. And then on the bottom, I'm going to write it in that same order. So no numbers to combine with. So it's 8. And then I have a squared, and I have b. So now I want to simplify. So 5 and 8 do not have any common factors. So that's going to be 5 and 8. There's 2 a's here and 2 a's there, so those cancel. 1b and 1b, right? And really, if you wanted to separate a squared on top and bottom, right, you could do that. So that one cancels, that one cancels. You can see that there's none left. So my answer ends up being just 5 over 8. All right, number 3. So let's start with the top, All right, let's start with the top. So my numbers, 2 times 3 is 6. And I have 2 x's, right? So we denote that as x squared. And I have 1 y. So that's y. I could write y to the first. Okay, I don't have to, but we can. And then let's go in order down here. So we'd have y squared and z. So now we have to go through and simplify. So numbers, 6 is the only number, so that stays 6. X squared, there's no other x squareds. So I'm just gonna, I wrote those over there. Allows me to see what's left. So down here, y squared, right? That's really y times y. And then I have one of them on the top. So I can eliminate one of each. And that means I have one y left on bottom. And then I have one z left on bottom. All right. Now, number 4, we got some numbers all over the place here. And again, you can simplify right now. You can multiply first. It's up to you. So I'll just show you kind of keeping the pattern that we've had before, right? 4 times 6 would be 24. And then I have x and x, meaning I have 2 of them on top. On bottom, I have 3 times 3, which is 9, and I have a y. So now we have to simplify this. 24 and 9 are divisible by 3, right? 23 goes into 24 8 times, and 3 goes into 9 3 times, right? So we divide out the common factor. There's only one x term, so it's x squared, and then I have y on the bottom. All right, take a minute and see if you can simplify 5 through 8. Okay, simplify 5 through 8. Pause the video here and come back and check. All right, number 5 is not done yet. All right, so just hold tight there. But I just multiplied each one straight across just so you could see where you're at. If you have this order different, that's not a big deal. I just like to put them in order. And we'll look at number 8. Maybe you simplified first, but let's look here at this. So I have 3 n's on the top and 1 on the bottom, right? So I'm going to just expand that to n times n times n, right? There's 3 of them. There's 1 on bottom. That means I can cross out 1 from each level, and I'm left with n squared on the top. Now I have 2 r's, right? That's what that's saying. So that's r times r, right? So I can cross away each there. So I'd have 1 left on top. And then I also have s squared left on top, okay? Both values on the bottom got crossed off. So this is good as your answer. If you want, you could put a 1 down there. Those are the same answer. In number 6, there was nothing to simplify, right? 2 times -4 was -8, and then you had an a on top, and then on bottom you had 3 with 2 b's, so b squared. No common factors between 3 and 8 other than 1, so that doesn't help me. So this is actually the final answer. Number 7, we had 5 a and b on top, and then b and c on bottom, right? So really I just did that, and I reorganized it so that my coefficient was out in front. So now there's a b on top and a b on bottom. So I'm left with 5a over c. Now, number 8, looking at it, I just multiplied, right? 4 times 18, and then there was an r and a t on top. There was a 9r and t squared on bottom. Now, some of you may have noticed, well, 9 goes into 18 twice, right? And then you would have had 4 times 2, which is 8. Well, so you could have simplified here, but if I look, 72 divided by 9 is 8, right? So it doesn't matter if I simplify first or if I simplify second, right? So I did 4 times 18 and got 72. And then 72 divided by 9 is 8. So let's simplify the variables. I have an r and an r. Those cancel, so none left. T squared, which means I have 2 of them on bottom, so I can cancel 1 each. 1 t left on the bottom. So there's my simplified answer. Dimensional analysis, right? So you look here, and that's a kind of a nice term to make it sound difficult, but these are problems that you've done in the past, right? Where distance equals rate times time. So it says the landing speed of a space shuttle is 216 miles per hour, right? So here's our dimensional analysis. We have miles per hour, right? Miles per hour, or a lot of times it'll be written as HR, right? MI over HR. Per just meaning divide. Said, how far would the shuttle travel in 1/3 hour during a landing? So we know, here's what we know. We know 216 miles every 1 hour, right? 16 miles per hour. 216 miles per hour. And we want to see, well, how far does it travel for just 1/3 of an hour? Okay, so just 1/3 of an hour. So, if you think of an hour goes 216, right? I want to find just this right here. What is this 1/3 section? So first of all, I know it's going to be less than 216, right? It's going to be a third of that, right? And so some of you might say, well, I'm just going to divide that by 3, okay? And that's completely fine. Dividing by 3 is the same as multiplying by 1/3, right? And so we're using hours here, right? This was my measurement. So really the hours will cancel out and my final answer will be in miles, right? So if I take 216 times 1 is 216, 1 times 3 is 3. So I have 216 miles, right, divided by 3. That is 72 miles in 1/3 of an hour. All right, so that's dimensional analysis. Sounds tricky, but you're just using units when you're solving the problem. So, short assignment today. I would like you to practice those, right? Practice those, especially the algebraic ones, because chapter 4, some of us struggle with that. So, again, if you have questions, you can join either of the 2 Google Meets for it's 8 to 8:30 or 1 to 1:30. All right, jump on, ask questions. If not, hope you have a great day, and we'll talk to you soon.